Hi, question number 11. The figure shows a trapezium ABCD in which AD is parallel to BC and AB is parallel to the y-axis. The coordinates of A, D and C are 2, 12, 6, 4, 13, 0. 2, 12, 6, 4, 13, 0. This one is parallel to this one. And we need the point X lies on BC such that BXA is equal to 90 degrees. We need to find the equation of BC, equation of this line. So we must remember this line is parallel to this line. Therefore the gradient of that line is going to be the gradient of this line. We've got a point here, 13, 0. So let's find the gradient of AD. And therefore the gradient of AD is going to be y1 minus y2. We have 2, 12, and then we got 6, 4. So 12 minus 4 is equal to y2 minus y1, 12 minus 4, divided by x2 minus x1, 2 minus 6. And that is going to be 8 divided by minus 4, and it's going to be minus 2. Now this gradient is also a gradient of BC because they are parallel lines. We need to find the equation of BC. We were told that the coordinates of B is 13, 0. So we're going to take a point xy and find the equation. Y minus 0 is y. It's equal to x minus 13, and then you multiply by the gradient. So the gradient times x minus 13. Therefore I got y is equal to minus 2x plus 26, and here we are for the first part, the equation of line BC. Right, we need to find the equation of line AX. Remember AX was perpendicular, the equation of this line. There is a point here, 2, 12. So we have A as 2, 12. Okay, and we can find the gradient of this line because it's perpendicular to this. The other one has gradient minus 2, isn't it? So the perpendicular line will have a gradient. So let's just call it the gradient of line AX, and that's going to be it's going to be half because product of gradient should give us minus 1 as the lines are perpendicular. So from here we can find the equation. So we're going to say y minus 12. Alright, y minus 12 is equal to the gradient, which is half times x minus 2. Therefore y minus 12 is equal to half x minus 2 times half is minus 1. And you can say y is going to be half x minus 1. You can send the 12 on the other side, becomes plus 12. So y is going to be half x, alright, plus 11. So that's the equation, alright, of line AX. First part of the question is done. Now for the second part, deduce the coordinates of B and of X. Now remember, this line is parallel to the y-axis. Okay, so we already have a coordinate here, 2, 12 is A, therefore B is going to be 2, and we don't know the y-coordinate of B. So for the second part, I know that B is going to be 2 and then y. Remember the equation, we can solve two simultaneous equations here. This line joins this line. So the equation of this line is what we just found. It was BC. The equation of line BC is y is equal to minus 2x plus 26. Y is equal to minus 2x plus 26. And this line joins B. This is x. So this can be substituted here. So we're going to say y is equal to minus 2 times 2 plus 26. And minus 2 times 2 is minus 4. 26 minus 4 is 22. Therefore, the coordinate of B is going to be 2 and then 22. Here we are. Now, and we need to find the point X. So we solve two simultaneous equations. Alright, and what are the two simultaneous equations? The equation of line AX, this is for AX we have y is equal to half x plus 11, and the equation of line BC, and that is y is equal to minus 2x plus 26. Therefore I can say half x plus 11 is equal to minus 2x plus 26. Alright, so x plus 22 is equal to minus 4x plus 52. You send this on this side, it becomes 5x is equal to 22. 52 minus 22 is 30, isn't it? Therefore I'm going to be left with 30 divided by 5 is 6, and hence I got the x coordinate of the point X as 6. What about the y coordinate? So we're going to say the y coordinate is going to be half x plus 11. So half times 6 plus 11. That is 3 plus 11, and it's going to be 14. Therefore, the coordinate of x is going to be 6 and 14. Here we are. Now, for the third part, determine the ratio of BC is to AD in the form of n is to 1. We can find vector BC, vector AD, right? Now, since I know that B is equal to, as found earlier on, 222, therefore the vector BC is going to be 222. No, sorry, vector OB is going to be 222. And then I have the point C. So the vector OC is going to be, the point C was 13, 0. I'm mistaken here. I should have said this is C. Yeah, from here, C, 13, 0. So I say 13, 0. Therefore, I can find the vector BC is going to be BO plus OC by definition of geometry. So this is going to be minus 2 minus 22, because the opposite of this, or the opposite direction, plus OC, it is 13 and then 0. Therefore, you're going to add these up. You're going to end up with 11 and minus 22. So this is the vector BC. Now, we can find the vector AD. We know that the coordinates of A was 212 as given in the question, and D is 6, 4. Therefore, the vector AD is going to be AO plus OD. And what is AO? 212 is going to be minus 2 minus 12 plus OD. OD is 6, 4. Add up, you're going to get 4 and minus 8. So that's the vector AD. We need to find the ratio of BC is to AD. So we're going to find the length of BC. So what are we going to do then? And so we're going to find the length of BC. That is, the modulus of BC is going to be 11 to the square plus minus 22 to the square, and you do the square root of that. So what is 11 to the square plus 22 to the square, and you do the square root of the answer, you're going to get this much. Okay, 25.9 something. That's going to be 24.5967 and so on. So that's 24.6. And what about the coordinates of, the vector AD? The vector AD has been found to be 4 minus 8. The other one is 11, 22. Yeah. So 4 minus 8. So it's 4 to the square. Here plus 8 to the square. It's going to give us 80. So that's square root of answer 80 is going to give us 8.944. So AD is going to be 4 square plus 8 square, and do the square root of that. You're going to end up with the square root of 80, and that's going to give you 8.944 something. Okay. Now, what is AD? What is BC is to AD? BC is to AD is basically BC over AD. I can say 24.5967, so on, divided by 8.944, and so on. Alright, so let's do that. So this is it, and I'm going to say the square root of 11 to the square, and check it out, plus 22 to the square is going to give this much. The square root of the answer divided by the square root of 80, which is this. So square root of, so divided by the square root of 80, 2.75. 2.75. And if you look, okay, so 2.75 is to 1, because we were told to give it as n is to 1. Therefore, I'm going to say 2.75 is to 1. Here we are. And for the last part, we need to find the length of AX and deduce the area of the trapezium. Now, what is the length of AX? The length of this. So I got, for the fourth part, the coordinates of A has been given as 212, and we did find X, and the coordinate of X was found to be, okay, a bit lost here with all these calculations, just quite heavy ones. Yeah, here we are, 614, right? So I'm going to say 614. So I can find AX. So AX is going to be then, well, first of all I need to find the vector AX. So, okay, so what is, oh, maybe I can use the formula 6 minus 2 to the square plus 14 minus 12 to the square. Alright, 6 minus 2 is 4, 4 to the square is 16, and 14 minus 2 is 2, 2 to the square is 4. So I've got then square root of 20. Right, now we need to find the length of BC. So we can use the formula to find the area. Now BC was found to be this, the square root of 605. Alright, and therefore the area of the trapezium, ABCD, okay, but right, so this is the length of AX. Now that's part of the answer. AX is going to be square root of 20. If you do that in your calculator, square root of 20 is going to give you 4.47, or you can say 4.47 if you wish. Right, the area of the trapezium is half sum of parallel sides times the perpendicular height, isn't it? So half sum of the parallel sides. Oh, I also need to find AD. AD is this much, root of 80. Right, so what is the sum of the parallel side? We got AD plus BC times AX, and therefore I'm going to say half times AD is 8.944 something plus BC, which is 24.5967 blah blah blah, and you multiply by AX, and AX is 4.47. that is 4.47. Right, so let's plug all these values in our calculator. 8.944 plus 24.5967, alright, and divided by 2, and then you multiply by the square root of 20. It's going to give you 74.999. So 74.999. We can, it goes on forever, so we can round this off to 75.0 units square. And here we are for this question. Quite a long one, but nice. Okay, hope you've enjoyed the video.